Hello everyone. Now this is the day 11 and lecture third for machine learning. Today we will learn about the decision tree. So I'm going to share my screen. Okay. Now today we will learn about the this decision tree, and only the theory part we will see, and the practical part we'll do later. Okay. So give me the 2 to 3 minutes for this. Hello. Okay, now I'm audible to all of you. So I'm going to explain the this things decision tree in machine learning. So this is the lecture third in machine learning topic, and this is the overall course for the A to Z complete GIS section. So we have learned Python, we have learned about the SQL, we have learned about the basics of the Python, and we have learned about the QGIS and all these things. So no, now come to the this section of the machine learning. Then we will go to the another higher version of this after the completion of this. And on day 30, we'll complete professional in GIS field. So starting with this, the first is introduction. Suppose a bank manager wants to decide whether a customer should receive a loan. He may ask, what is the customer incomes? Does the customers have a job? What is the credit score? Has the customer taken loans before? Based on the answer, he makes a decision. And this is a decision tree works the same way. And this is the decision of the bank's worker. But in a machine learning, the decision tree works in a same fashion. So instead of human asking question, the machine automatically does the best questions from your data. So definition for this machine learning in the topic of the decision tree is supervised machine learning algorithm that predicts an output by repeatedly dividing the dataset into smaller groups using a sequence of decision rules. The model creates a tree-like structure consisting of root node, decision nodes, leaf nodes, and branches. The goal is separate similar observation into the same group. So why was the decision tree developed? Imagine a dataset containing 10,000 customers. Age is this 25, 40, 35, and 22. Income low, high, high, low. Low, no, yes, yes, and low. This is the decision. So humans cannot manually find rules from the thousands of the record. Decision tree automatically discovers patterns such as if income is high, approve the loan. If income is low, reject the loan. Thus, decision trees convert raw data into understandable decision rules. Okay. What problem does it solve? Decision tree solves classification problem. Output is a categorical. Example: pass, fail, disease, no disease, spam, not spam, food, not food. Regression problem. Output is numerical. Example: house price, rainfall, groundwater level, temperature. Structure of decision tree: income high, loan yes, low loan no. Root node, the first question example income, the most important split. Decision node, immediate questions example age is 30. Leaf node, final prediction example loan approved. So branch connection between nodes example yes or no. How does a decision tree thinks? Create group that are the pure as possible. Pure means all observation belong to one class. Example group A yes 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 yes. Pure group B yes, no, yes, no. Impure group, decision tree always tries to create a pure group. Okay. Mathematical foundation, the biggest question: how does the tree know which question is the best? Example should be split using A's income equation. The answer come from entropy, information gain, Gini index. Okay. Then what is the entropy? Entropy measure disorder or uncertainty. High entropy mixed data, low entropy pure data. For example, entropy is minus some p minus a log 2 and pi, where p is a probability of each class. Example data set. Yes, no. Total 10. Probability of yes is 5 by 10. 0 point probability of no is 5 by 10. 0 point entropy formula, entropy minus n summation n I is equal to pi log 2 pi. For binary classification, yes oblique no, entropy is equal to minus pys log 2 pys plus p no log 2 p no. Example, yes 5, 5 no. Calculate probability p yes 5 by 10 is equal to p no 5 by, both in the case of the 0 0.5. So apply entropy in this formula, solve and use. Therefore, you got this. Entropy is 1, result 1. 1 means the data is highly mixed, maximum uncertainty. Okay. Perfect pure node, yes is 10, no is 0. Apply formula. This entropy minus 1 log n 2 1 0 log 2 in this thing. So entropy is 0. Interpretation, 0 perfectly pure node, 1 maximum impurity for binary class, low entropy better split. Decision trees try to reduce entropy at every split. So maximum disorder, now suppose yes is 10, no is 0, every income, perfect information gain. Now convert information gain. Decision tree aims to reduce entropy. Reduction in entropy is called information gain. Okay, if the entropy is less, then your result will be good. Formula, information gains entropy parent minus entropy children. High information gain is equal to better split. If information gain is in high, then your result will be best. Example of information gain, parent data set 5 and 5 is the no. Entropy is equal to 1 after splitting by income. High income 5% have yes, no, and 0% is no. Entropy is 0. Low income, yes, 0 and 5. So entropy is 0 and child entropy is this. So information gain is 1 minus 0 is equal to 1. So perfect split, therefore income becomes the root node. So give me the 5 second for this. I'm going to do, what will you do, just chat to something. Hi everyone. Okay, now go to this. Okay, we will take the 5 minutes this uh break, then we will do continue. Okay. Okay, now start with this things. So we will understand what is the Gini index. The Gini index is a measure of impurity or disorder in a data set. Decision trees use it to find the best split. The formula is Gini index 1 minus summation n I pi is equal to r square, where Gini is Gini impurity, pi is the probability of class I, and n is the total number of classes, and summation sum of the class probabilities required. So for binary classification, if there are only two classes, yes and no, the formula becomes this: Gini is equal to 1 minus p square yes and p square for no. Example 5 and 5 for yes and no. Calculate the probability. This is the zero point 0.5, this is the zero point 0.5, yes and no. So apply formula Gini is equal to this and this, and then finally solve is Gini is equal to 0 0.5. So 0 0.5, this indicates that the node is a mixed, that is the impure. So perfectly pure node, yes and 10 is 0, probability is yes is for this and this. So Gini is the 0. The result it gives you the 0. It's a Gini value of 0 means the node is a perfectly pure because all observation belongs to the same class. So important note that the lower Guinea better split, Guinea 0 perfectly pure node, higher Guinea more impurity. A decision tree always tries to choose the split with the lowest Guinea index. So training process. In step 1, take the complete data set. Step 2, the calculate the entropy of the Guinea. Step 3 is try every feature. Step 4 is to find the best split. In step 5 is to choose the split with the highest information gain. And step 6, create branches. Step 7, repeat recursively. And step 8, stop when pure nodes are obtained. Overfitting problem is may become so for this a tree can continue splitting forever. Example is more than 35, income is fifth, more than 50, experience is more than 50, city is Delhi, household is own, blah blah blah. The tree memorized training data. This is called the overfitting. Parameter maximum depth, maximum tree depth, and minimum sample split. So this will be more clear when we will do the this with your practical class. Okay. So minimum observation required to split, minimum sample sleep, minimum observation in a leaf, P running, removing unnecessary branches. So decision tree versus logistic regression. Both decision tree and logistic regression are supervised machine learning algorithm used for classification problems. However, they make prediction in different ways. Decision tree is a makes a prediction by asking a series of question, working process, question to decision. Example, attendance is more than 75 minutes. Yes. Study hours is 2 hours. Yes. Then you are the pass. The model keeps asking question until it reaches a final decision, and this characteristics a rule-based approach, easy to understand, easy to visualize, and similar to human decision making. So in previous case, we have read about the logistic regression. And what will the logistic regression done? Logistic regression makes prediction using a mathematical equation, calculate a score Z, and this the linear score, b naught in intercept, and b1 with the model coefficient, weight, and exponential input features. That is independent. Suppose A is 30, salary is 50, and the model learn b is not equal to minus 5, b1 is 0.1, b2 is equal to 0, then this is the this z is equal to 10. This value of z is then passed into sigmoidal function. We have read about this. So the calculate probability, one line. Notice that the equation in this is combines all input feature into a single score, which then convert into a probability using the sigmoid function. So calculating probability where p is the probability of positive classes. Example pass, yes, approved, Euler's constant 2.7, and linear combination of input features, and this equation, that is this linear combination input feature, this equation. Simple meaning, we have read about these things in previous class and no need to explain this thing. So key difference is decision tree input data, question, and final decision. Logistical input data, mathematical equation, probability, and final decision. So comparison table, working style question based and logistical equation based. Output decision rules, probability based rule, output in this logistic design. Easy to understand, yes. And this is the logistical little bit tough comparatively to decision tree. Visualization easy and in visualization difficult. Human interpretation high, and in this case medium. Mathematical complexity low, moderate. Decision tree versus random forest. Decision tree one tree, random forest hundreds of trees. Decision tree fast, simple, explainable. Random forest more accurate, less overfitting, more complex. So advantage: easy to understand, easy to visualization, no feature scaling required, working with non-linear data, and handles numerical and categorical variables. Disadvantage: overfitting, sensitive to small changes, and lower accuracy than ensemble method, unstable on noisy data application, medical diagnosis, loan approval, customer churn prediction, groundwater quality classification, land use mapping, flood sustainability mapping, crop prediction, weather forecasting. So final interview question is asked: a decision tree is a supervised machine learning algorithm that learns a series of decision rules from data and recursively split the data sets into smaller groups to make prediction. So it selects the best split using impurity measures such as entropy, information gains, and Gini index in indenting to create a pure group and improve prediction accuracy. So this is the overall brief introduction of the decision tree in machine learning. So we will learn these things in next class, and try to run some codes on real data, and this will be more clear when we are doing the practical knowledge. So let's see, we will meet next class in day 11 class, and with lecture 4, and continue with the decision tree. So thank you so much for watching this video, and participating in last session. So bye bye, thank you so much.